Alright everybody, welcome back. Today we're going to continue our exploration of render picking, and to do that we're going to jump right into things. So here we can see the system we're going to be working with. I'm actually starting from the tutorial that I published most recently, which was rendering point clouds using Particles GPU and a PBR rendering technique. You don't necessarily need to use this technique to start, but I do think that it will smooth things, because I'm not going to go over how to set up kind of this particle system. I'm just going to be talking about the render picking aspect of things today. So you can either go check out that tutorial and go build it yourself following along YouTube, or you can just go over to my Patreon and grab the project files and get going from there. So, without further ado, let's reset this and take a look at our render picking. So here I'm just using the mouse. I'm able to click on a couple instances, and we can see that clicking will enlarge the instance and change the color. And I can click and drag and kind of paint these instances as well while I'm going, which I think is pretty cool. But this is not the only thing we're going to be doing today, because you could do exactly what I'm doing here with the normal render picking setup that we went over in the last render picking tutorial. So let's reset again, and I will jump into the actual network. So here's an example of something else that you can do with this system. And that is actually use other, here we go. That is actually use other data besides MultiTouchInDAT to actually run that render pick. So here I'm moving two circles around the screen, just purely in screen space. And as those circles are kind of going over different instances, we are changing those instances based on the circles themselves. And so this is cool because you could not do this with a multi-touch setup, and while this might seem a little bit contrived, it is a good illustration of a broader principle, which is using any data that you want to do render picking. And by that, I mean you could use LiDAR data, you could use Connect point cloud data, blob tracking data, leap motion, and many other sensors that could all be used here to facilitate the render picking. So, yeah, I think this is something good to explore, and a technique that I've been using a lot in my recent work. So, I'm going to basically just delete the stuff that I've recreated, and we're going to start from this point cloud alone. So we'll delete this, we'll delete this, and then I just have to fix couple things here that I changed, and there we go. So again, I'm using the function store toolbar up here to make quality of life a lot better in TouchDesigner. Feel free to go grab that from his GitHub. It's open source, but you can also support him on Patreon if you want. And yeah, so basically where we are right now is from YouTube. Let's say my videos, and here. So we are, there we go. I'm starting right where this Point Clouds with Particles GPU tutorial is leaving off. So, like I said, we have our point cloud, we have all of our kind of rendering and everything set up. And so what we really need to focus on today is just that render picking setup. To make this a little bit better, I'm going to change my resolution to a vertical aspect ratio. I'm going to use Alt and left bracket to split the screen here. I'm going to turn this into a panel and point it at the project. This is what we'll actually use for our render picking, but it will also just let us visualize things a little bit nicer while we're working. We need an out. There we go. So now we have this nice, nice setup. And I'm going to turn this speed down a little bit so that it is not quite as hectic as we're just sitting here and working. All right, so to get into things, what do we need to do? First things first, let's grab a panel and point this panel at our project component, or whatever component makes sense for your setup, but I'm going to use that project component. I'm going to then use a select. I'm going to grab the channels L select, inside U and inside V. And then I'm going to use, or drop down a render pick. So basically what we want to do, I guess just to refresh really quickly the kind of normal way, is to use a multi-touch in, include mouse events, point it at our project panel, and then you can see that our mouse UV and everything is updating. And if we wire that into the render pick and turn it on and point it at our render, then we can see that as we are clicking with the mouse, we're selecting a geometry. I'll turn on my instance ID in the render pick, and then we can see when we click on an instance, we do get that instance ID. This is with the multi-touch in, and again, the whole point of this tutorial is to move beyond that, so let's move beyond it. What we're going to do first is just recreate that multi-touch in with the mouse data itself, just using the panel to kind of build some intuition, and then we'll go to the slightly more involved setup. But first, let's understand what we need to look at for this data. So, this render pick DAT needs to be fed another DAT with 3 columns minimum, select U and V. They say MultiTouchInDAT is usually connected here, but again, doesn't have to be. So what we're going to do is just create that DAT from our panel information. And so we're going to first use a rename, and we're going to rename these columns to select U and V so that they match the specifications for our render pick DAT. Select U and V, and then now what we can do is just use a chop to DAT, make sure we include our names, and then just wire this right into our render pick. Now I'm going to drop a null after the render pick. I'll call this picked. And then I'm also going to do a quick DAT to chop here. Make it a channel per column. First row is names, first column is values. And then I'm going to use a select. And I'm going to grab just that instance ID. So this way, we'll be able to see kind of live as we are picking instances, which is great. And now you can see that with my mouse, I am able to select instances, and the render picking is working. And we have our instance ID right there. Now, you can, of course, use similar techniques to our last tutorial to move these instances around, but today I'm going to focus on changing the scale and the color of these instances because, one, we didn't do that last time, and two, for a particle system where there's kind of already pre-dedicated or pre-computed motion, you might not necessarily want to be changing these instances' locations, but rather other attributes. So I'm going to just clean this up a little bit. And yeah, so before we go into changing the scale, I'm just going to go over how to use that circle overlay. And so for this, it'll be very simple. We're going to grab a circle. We're going to make this pretty small, like 0.02. I'll make sure that the resolution is going to be the same as my project resolution. And then I'll copy and paste that. I'll use a noise chop I'll use a noise chop, noise. We'll turn on time slice, and then I'm going to give it 2 channels, XY, and then 2 more channels, call it just XX and YY. I'll make this period something like 20, and then I'll make my amplitude 0.5. Now, I'm going to drop a null here, and then what we can do is just drag and drop this circle X and Y onto our center for circle 1, and then XX and YY onto our center for circle 2. So now we have these 2 circles that are moving about. Can connect them together. Call it null circle overlay, just like that. And then we can use parameter chops. Point this parameter chop at the circle. Make sure to turn off custom and on built-in because we're using built-in parameters here. And then we want the parameters center X and center Y. And then we'll just copy and paste that, drag circle 2 onto it. And then we have these 2 parameters which we can join together. And that's great. We can then rename this to U and V, which is ideal. And then we can start to use this for our render pick data. But first we need a select column. Now there's several ways that you can do this. I'm going to cheat a little bit here and actually just grab the fill alpha parameter for each of my circles. And what that's going to do is return a value of 1. Whoops, space there. Return a value of 1. So this is going to basically be like an always selected kind of situation. Yeah, you could definitely make that change or dynamic, use some noise to drive the alpha, or use a constant chop that is going to be always on. You could well, actually, I would probably do a constant pattern like this, but then you have to mess with the length and everything, so whatever. I'm just going to do the quick and easy fill alpha, and then I just need to change my rename to select U and V. We'll drop a null after that, and then we will do the chop to dat, include names, and there we have this that we can use. I'm going to drag and drop that with Alt drag, and using again the function stores toolkit that just creates a select that points at this operator. You could of course just use a select to dat and then drag and drop this on. So now what do we expect to happen when I drag and drop this into the render pick? Well, we would expect this to now have 2 instance IDs that are updating based on where the circles are. But it would help to be able to see those circles first, so I'm going to click on my null circle overlay, Alt, drag, and drop to create this select. I'm going to add in an over, and flip these inputs around. And so now we can see my circles are over top of my point cloud. I'm going to make them red to make it a little bit easier to see. And maybe just turn on the softness ever so slightly. And actually, I think I'm going to turn up the radius a little bit too, just to make it a little bit more clear where those circles are. Okay, so now we can turn in, or wire in this render pick. And we can see that we're starting to actually select some data. Now, this data doesn't look quite right. We can see that we're, right now, for example, not returning any instances. That's a -1, meaning there's no instances underneath our point. But that's not true, right? We can see some instances here. And so something is not quite right. What that something is that our circle centers are from negative 0.5 to positive 0.5, but our render pick is expecting a UV between 0 and 1. So what I'm going to do here is just insert a math after my rename. I'm going to scope it to just U and V, and then we're going to rearrange from minus 0.5 to 0.5 to the range 0 to 1. Now when we're render picking, if we zoom back in here, maybe view this. Yes, and then we can see that we are indeed returning instances underneath both of these circles as we would expect as well. So now that we have that kind of setup built, you can see, one, that you can use pretty much any data as long as it's properly mapped in the 0 to 1 UV input range to drive your render pick. And like I said before, these circles are really just a simple example of how that setup can work, but could easily be replaced with any other sort of input from sensors or whatnot. Okay, so now we need to actually start this feedback loop to update our instances. So I'm going to drop down to select. I'm going to grab my scale op here, which actually, I think maybe this path needs to be updated because we're not in container 1, we're in point cloud particles. My apologies for that mistake. Okay, so you can see the scale is now properly updating. Before it was not, which is great. And then this is going to be selecting our scale. So now we want to use this scale to create a little feedback loop that's going to take in our instance data, take in the render pick the chosen instances, and then do something to those chosen instances based on whatever we want. So we're going to do that with just a little bit of GLSL. First, I'm going to use a reorder top, and I'm going to grab the red for the red channel. I'm going to grab 0 for the green channel, 1 for the blue channel, and 0 for alpha. We're not going to use that one. Then I'm going to drop down a feedback. I'm going to drop down a GLSL multi. We'll do a null, call that end feedback. And then I'm going to have another null, and we're going to call this picked data. Okay. So let's move this feedback up a little bit for clarity. Point the feedback top to the end feedback. And now we can get going. So first, there are two things that we want to do. We need to create a way for this GLSL shader to understand what instances are being picked. And we need to define a couple parameters that are going to help us scale that instance. So I'm going to call this useScaleRate, and I'm going to set it to 0.1 for now. And then in the arrays, we're going to set up a sampler called sPickedInstances. This chop, I'll drop a null after I select, and I'll call this picked instances. And then drag this null onto our chop, and then change the array type to a texture buffer. Now we can edit our shader. Let's see. Okay, that actually works pretty well. And so now we can start working. So the first thing we need is to define that uniform float uScaleRate, which is what we have already defined over here on the GLSL shader. And then we need to define a uniform sampler buffer that is called spict instances. Now we can use this data and start to update things. So first things first, we need to just read in what our scale data is. So I'm just going to call this data, and then we'll say float scale equals data.r, float picked equals data.g, and then float color equals data.b. Now we'll output data. Data. And we're working so far. So now we need to loop through all instances picked. And so for that we can use a for loop for int I equals 0, I less than, here we're going to need another uniform, we'll call it num picked instances, and then I plus plus, set up your brackets, and then we have to go declare this uniform int u num picked instances, and then in our vectors here, u num picked instances. And this is going to be the number of samples in our op that we called picked instances. .num samples. Just like that, and this is an optimized expression, which is great, it means it'll run really nicely. And so now we can have this for loop that's going to run through all of our picked instances. So then we will grab the current instance ID, and for this we need to actually sample that texture buffer. So that will be using texel fetch spict instances, and we're going to sample using the I, which is the coordinate that we're on in our loop. And then we'll just grab the first value. And we'll need to wrap that in an int so that we can cast it to the right type. Okay, so now we have our instance data. The next thing that we need to do is understand whether or not an instance is actually picked, because there may be cases where there is no instance underneath a touch, and that will return a -1 as we saw earlier. So the first thing we need to do is say if instance ID is greater than 0, then we'll do something. And now we need to convert instance ID to texel coordinates. And so to do that, we are going to use just a couple lines. First, we'll have our x texel coordinate, and we'll set that equal to our instance ID modulo. And here we'll use another int casting, and we're going to use a built-in uniform td output info.res.z, which is the x coordinate of the resolution, i.e. how many pixels long our texture is. Using this mod will mean that regardless of what row of pixels we're on, we will just get how many pixels from left to right that texel is kind of sitting on in our texture. To grab our y coordinate, we use a similar operation, but here we're going to use an int cast and then actually take the floor of our instance ID divided by that same utd output info.res.z. And so now we have an x and y coordinate that are going to be equal to, that are going to represent which pixel in our shader, or really in our instancing texture, the instance that's selected is associated with. So now if the instance that if the texel that the instance is associated with is the same texel that our shader is operating on, then we want to do something. So we need to have another test. We'll say if x equals int gl fragchord.x and the double ampersands y equals int gl fragchord.y, then, and we can just comment this and say if our selected instance is the same as the texel we are operating on, then what do we want to do? Then we want to change something. And so we can say scale times equals 1 plus u scale rate and then down here I'm going to set data.rgb equal to vec3 using scale and then picked and then color. And we'll get rid of these. And so now if we reset this feedback, well, nothing's really happening, but that's because we need to update our scale op to be this picked data. Now when we reset things, and I'm going to actually go back to using the mouse here to make it a little bit more clear, we can see that every time I'm selecting an instance, its scale is indeed growing. Okay, so there are a couple other things that we need to do to kind of bring this together, because right now it's not looking so hot. So one of the things that we might want to do is actually keep track of where our instances are going to be placed or rather keep track of what instances we touch and increase the scale of. And so for that, we can do something like using the picked value that we're storing in our green channel and actually update that using the same use scale rate. So if our scale, or rather, if our instance is the one that if our texel is the instance that we're operating on, then we want to increase the scale. We want to increase our picked value. And if that's not the case, what do we want to do? Well, if picked is greater than 0, this means that it has been picked before. Instance has already been picked. Then we want to not do anything because we want to retain that higher scale. And then last but not least, if there is anything else, we can actually just reset the scale to our initial scale. And so maybe it would be helpful to, in here, have the selected scale or really this reorder actually just wired into our GLSL again. We can then create a define scale, or actually define data, that will be 0, and then define init scale as our first input. We can sample the data input for our data, and then we can just copy and paste that and select the initial scale. And so now we have this vector, initial, and actually I guess I should call it initial data. And so now we have an initial data that will help us when we want to be able to put things back to kind of how they were at the beginning. So then we could say scale equals initData.r. So we can see that here, now as I'm clicking, this instance is getting bigger for sure. And that's going to give us something to work with, but I think that there is a mistake somewhere that I've made. And aha, I see what it is. It's because I used this select, actually referencing this picked data and not referencing the actual point cloud information in the particles GPU. So I was creating this like giant feedback loop that was messing everything up. So instead of having this be op.geo3.par.instanceOp, I want that to be the actual explicit reference, which is going to grab the scale data coming out of particles GPU. So now I can reset my feedback. And there still seems to be something a little bit wrong. Okay, so I realized the mistake that I was making, and so I'm clicking and nothing's happening. But if I make this full screen and we take a look and do this again, you can see we're getting a little warning here. And that warning normally means there's like a cook loop dependency. And so to fix that, it's actually pretty simple. We just need to insert a feedback chop and basically just delay our picked instance by 1 frame. And so this will now allow us to click on an instance and have it be growing, which is what we want. Now, this is getting a little bit chaotic because, well, it is just completely going to grow, and this instance number stays until we pick a new instance. And so that's why selecting an instance kind of causes it to like grow into perpetuity forever. So that is why when we kind of flag a picked instance and increment, we want to use that data because we are outputting it into our feedback loop. So then we want to add here, and picked is less than 1. This will mean that now we only grow up to a certain amount based on basically 10, or I say 10 because our scale rate is 0.1. It will only scale while this picked value is less than 1. And so that is going to limit the scaling and also result in a smooth kind of animated curve to these instances growing, because it basically takes 10 frames for it to go the whole way to its new scaled height. If we make this bigger, we see it happening fast. It's actually even harder to see. And if we make it smaller, we can see it takes longer for the instance to grow. I'm going to leave it at 0.1 for now and reset. So now we're basically saying if we have not scaled if we have not scaled too much, meaning if there's still scaling left to be done, if this picked value is less than 1, then we will scale. Otherwise, if it's picked, we should not do anything because it has already been picked and we don't want it to be just, again, continuously scaled. And otherwise, meaning if it is not the texture at all, not the active textile at all, and also has not already been picked, then we can just set this scale equal to our initial data. Now to change the color, which I believe is the other thing that we did, this would be very simple. It would actually just be color equals, I mean, I'm just going to say 0 here, and that doesn't necessarily mean anything, but I think it's the most clear to see. We can go over to our geo and actually instance this with picked data channel B. So now when I reset everything and then go in and click, we are now scaling these instances and also turning them black. Now, obviously, if we change this, now we're just darkening them, not making them fully black, and so maybe make it like 0.25. And maybe that's nice because they get dimmer. They're obviously interacted with, but they are not fully black. Okay, so that is definitely getting there. Now we can wire in our little circles and see how this works. So now we can see as those circles are moving around, they are leaving a trail of increased touched instances that are both dimmer in color and larger in scale. And again, this can be done using really any type of input data, not just our panel and not just this kind of rudimentary circle chain that we've set up. So I'm going to clean this up a little bit. This will be feedback loop to alter picked instances, and then this will be render picking set up. And this is a lot of the way there. Now, there are a couple other things that you may possibly want to do. One thing could be to add something like, if the instance has already been picked, maybe we want to try and actually scale it down a little bit. So we could say scale divided equal, and here we could say 1 plus u scale rate over 2. Now, that might cause some instances to actually go down to 0, which you might want. It's kind of cool. So now they're kind of getting bigger and then disappearing. If you don't want that, you can set the scale to be the max of the scale and the initial data.r, which is our initial scale, and that will prevent the instances from going any smaller than that initial scale, but we'll still get the kind of momentary enlargement. And you can also make this much smaller, and that will then kind of give you more of a fall-off curve. So if I wire this in and touch, so it gets big pretty fast, and then it takes a while to scale back down. You can then obviously, like if you make it even smaller, maybe like 50, that will then really slowly scale back down. We can parameterize that. We can say u decay factor, call that 50 for now. Go up here, add it to our uniforms, u decay factor, just like that. And then we can use that u decay factor. So I guess now maybe it's time that we customize our parent component. we'll have a parameter called decay factor. This can be a float. Now we definitely want to make sure that it's not 0 because that'll throw some errors. So we'll make the range, let's say 1 to 100. Drag and drop that on. So now it's going to be really fast, right? 1 up, 1 down. And this will be about as slow as it can get. We could also break apart this scale rate so that we can have the scale actually increase at a factor that's different from the factor that we're incrementing this picked value at. So to do that, we could say maybe U scale, I don't know, time. And so then we can have a parameter called scale rate, and that should be 0 to 1. And then we can say scale time, also 0 to 1. And then we'll set this scale rate to 1.5 and this scale time to 1. And so now it's getting a little bit bigger. If this is much bigger, then we can see the relative size of the... Actually, we don't see that right now because we need to, one, add this as a uniform, use scale time, and then use that use scale time here at our picked increment. Oh, there you go. So that might have been, maybe the scale rate's a little too high. Maybe it shouldn't go quite the whole way up to 1. Maybe we'll cap it at like 0.3. I don't know. Something like that. And so now our scale is getting a lot bigger. And as we increase the scale time, there's less and less of a curve. Whoops. If this scale time is much smaller, then there is a much more defined curve between a minimum or beginning scale and ending scale. And then of course this decay factor we can change as well, and that will be how quickly the instances are going to return to their previous size. So I'm going to set this at 0.15. I'm going to set this time to 0.1. I'm going to set this decay factor to 25. And I think that's a pretty good animation at the moment. We'll wire in our circles again. And there you go. Now we have these circles that are manipulating our point cloud as they are moving around in screen space, remember. These are just tops, not stops at all. And so I think this is a pretty good example of how to use alternative data for render picking that will really allow you to have full flexibility in the particle systems and interactivity with those particle systems in a way that without render picking is quite difficult to achieve. So I hope you all enjoyed this. I will put the project file on my Patreon as always, and thank you to those of you who support me. If you're watching on YouTube and this has been beneficial, hit like, hit subscribe, and help me out in that way. So with that, I will leave it. Happy creating, and I will talk to everyone later.